In the depths of the universe, the simple and the complex intertwine in a perfect balance. This audiobook accompanies you for 2 hours on a journey that unites science and wonder, from the light that revealed the most intimate secrets of physics to the mysterious quantum processes that pulse in life itself. You will discover how ideas born to explain a lit bulb led us to understand the strange behavior of invisible particles, and how those same hidden rules govern everything from the flight of birds to the photosynthesis of plants. Because understanding the physics of the universe is not just about learning about the cosmos, it is discovering the invisible fabric that connects everything, including us. Science, often seen as a labyrinth of formulas and theories, is, in essence, a quest to understand what surrounds us. Have you ever felt overwhelmed by the vastness of the universe? Perhaps you have looked up at the starry sky and wondered why the stars twinkle or how gravity affects everything we know. Science not only offers answers, it also invites us to ask deeper questions. In this journey, we will explore how light, that source of energy that illuminates our lives, has been fundamental in unraveling the secrets of the universe. But did you know that light can be both a wave and a particle? This enigma has fascinated scientists for centuries and has led to discoveries that have changed our understanding of physics. Light, in its purest essence, is a bridge between the tangible and the abstract. As we delve deeper into this topic, it is intriguing to think about how the invention of the light bulb not only illuminated our homes but also sparked a revolution in the way we understand the world. What if I told you that this small invention was the catalyst for developing quantum mechanics? For a long time, classical physics seemed sufficient to explain reality, but the advent of artificial light revealed new dimensions of knowledge. When we look at light, we often think of it as something simple and straightforward, a ray that allows us to see. However, behind this simplicity lies a dance of particles and waves that challenge our intuition. It is like trying to see the surface of a calm lake without imagining what lies beneath. Light, like that lake, has a depth that few dare to explore. Let us imagine for a moment the relationship between temperature and the color of light. Why can a flame be red or blue depending on its heat? This dilemma was the starting point for a scientist named Max Planck, who became embroiled in a debate that would change the course of physics. The search for answers led Planck to discover that light not only behaves like a wave, but also has a quantized nature. Thus began the era of the ultraviolet catastrophe, a term that reflects the chaos that can arise when the known confronts the unknown. As we progress, it is essential to understand that light is not just a physical phenomenon. It is also an emotional and philosophical bridge. It connects us to the universe and invites us to contemplate our existence. But what happens when we start to question the nature of light itself? The photoelectric effect is one of those examples where light challenges our preconceived notions. How can light, which seems so ethereal, generate electricity? The journey does not stop here. The duality of light, that strange ability to be both a wave and a particle, opens a new chapter in our story. Albert Einstein, who revolutionized our understanding of time and space, delved into this mystery. The way a simple photon can behave differently depending on the context is something that still leaves us in awe. What implications does this have for our understanding of reality? Now, imagine an experiment that resembles a magic trick. The double-slit experiment is one of the most astonishing demonstrations of quantum mechanics. When you shoot electrons through 2 slits, they can behave like waves, creating interference patterns. But if you observe the experiment, the electrons decide to act like particles. How is it possible that simple observation changes their behavior? This question leads us to the Copenhagen interpretation, where quantum reality manifests in ways that challenge logic. As we delve into quantum entanglement, the interconnection of particles becomes an even more perplexing concept. Is it possible for 2 particles to be connected instantaneously, regardless of the distance separating them? This phenomenon challenges our notions of space and time and raises questions about the nature of reality itself. Bell's theorem emerges as an attempt to unravel these mysteries. Through experiments and equations, The nature of quantum reality has been explored, raising more questions than answers. Science becomes a journey of exploration where each discovery leads us to new horizons. The idea that our perceptions might be limited by our current understanding is both fascinating and unsettling. Thus, in this journey, quantum mechanics not only becomes a field of study, but also a window into the very nature of existence. As we move forward, we will discover how these abstract concepts have repercussions in everyday life. From the navigation of birds to our perception of smell, the magic of science lies in its ability to connect the micro and the macro, the simple and the complex, blurring the lines between what we think we know and what we still have to discover. This journey through light and quantum mechanics is just the beginning. Science is an invitation to explore, to question, and to marvel at the universe. As we delve into each of these topics, let us remember that each discovery is a step closer to understanding what surrounds us. The simplicity behind the complexity of the universe awaits us, ready to be revealed in every corner of our journey. The story of light is one of the most fascinating in science, and its impact has been profound and lasting. In ancient times, light was considered an almost magical phenomenon. Philosophers and scientists, from Aristotle to Newton, tried to decipher its nature, but it wasn't until the invention of the light bulb that our understanding of the universe truly began to change. Did you know that the simple ability to illuminate a room could trigger a revolution in physics? When Thomas Edison patented his light bulb in 1879, he not only lit up streets and homes, but also sparked a fire in the minds of scientists. Light, which had previously been understood mainly as a visual phenomenon, began to be seen as a form of energy that could be studied and manipulated. This led to a radical shift in how the physical world was conceived. What discoveries led scientists to question what they thought they knew about light? One of the most intriguing questions that arose was how the temperature of an object related to the color of the light it emitted. What seemed to be a simple connection turned out to be a profound dilemma. Max Planck, a German physicist, found himself in the midst of this mystery. While studying the radiation of a black body, he realized that the emitted light did not behave as expected. Why does the color of an object's light change when it is heated? When Planck proposed his famous constant, he began to glimpse a world where energy could not take on any value but was quantized in discrete packets. However, his discovery was not well received at first. This phenomenon, known as the ultraviolet catastrophe, challenged the notions of classical physics. What happened to the perfect image we had of the universe? In this quest for answers, another great name emerged. Albert Einstein. His work on the photoelectric effect revealed that light, in addition to being a wave, also had particle-like characteristics. How could it be that such an ethereal phenomenon as light had such a dual nature? For Einstein, this duality was not only a mystery but also an open door to new possibilities. The idea that light could behave like a wave at one moment and like a particle at another made many scientists reconsider the nature of reality itself. What does it really mean for something to be two things at once? This question led to the formulation of quantum mechanics, a theory that blurred the lines between the known and the unknown. A crucial experiment that helped cement this new way of thinking was the famous double-slit experiment. This experiment surprised scientists by demonstrating that electrons, when observed, behave like particles, but when not observed, act like waves. How is it possible that mere observation affects the behavior of a particle? This phenomenon led to the Copenhagen interpretation, the idea that quantum reality is influenced by our observation. In this context, two giants of science, Einstein and Niels Bohr, found themselves in an intense debate. While Einstein defended a deterministic universe, Bohr embraced quantum uncertainty. Which side of the discussion had a greater impact on our understanding of the universe? As we delve deeper into the quantum world, we encounter concepts that further challenge our intuition, such as quantum entanglement. This phenomenon suggests that two particles can be instantaneously connected regardless of the distance that separates them. Is it possible that information can travel faster than light? Bell's theorem emerged as an attempt to address these questions. Through experiments and mathematical equations, scientists sought to validate or refute these ideas about quantum reality. Could scientists finally solve the enigma that had puzzled the scientific community for decades? Experiments conducted by physicists in Berkeley in the 1970s not only provided answers but also reflected the spirit of an era. Science intertwined with culture, challenging the boundaries of what was considered possible. How did this cultural context influence the scientific advancements of the time? The experiments of Clauser and Aspect were pioneering in confirming the quantum nature of the world. Their findings not only revolutionized physics but also led to new questions about the nature of reality. What does it mean for us as human beings that the subatomic world does not behave in the way we intuit? Ultimately, all these explorations lead us to reflect on our place in the cosmos. Light, which was once merely a visual phenomenon, has led us to a deeper understanding of reality, revealing surprising connections between quantum mechanics and the processes that shape our existence. Are we ready to continue exploring the mystery that surrounds us? The answer could change our way of seeing the world forever. If you're enjoying this journey through the universe and want to keep exploring more cosmic mysteries, don't forget to subscribe to the channel and give the video a like. Thank you for being part of this Star Odyssey. The relationship between temperature and the color of light has fascinated scientists for centuries. But what happens when logic meets a puzzle? In the 19th century, Max Planck became a pioneer in trying to understand this connection. The story begins with an intriguing question: why do objects turn different colors when heated? Imagine a slice of bread in a toaster. At first it is a pale color, but as the heat increases, it transforms into a crispy golden brown. What is happening in that process? Planck immersed himself in the search for an answer and encountered a great challenge: the ultraviolet catastrophe. This phenomenon refers to a problem in the physics of his time, where existing models could not explain the radiation emitted by black bodies, which are those that absorb all light that falls on them. In other words, when an object was heated, its color did not follow the expected logic. Instead, experimental results seemed to contradict the laws of classical physics. As Planck explored, he realized that he needed a new way of thinking. The key was to understand that energy was not emitted continuously, but in small discrete amounts, which he called quanta. This idea surprised his contemporaries. How could energy behave so peculiarly? The notion that energy comes in tiny packets was revolutionary and laid the groundwork for what would later become quantum mechanics. But the story doesn't end there. Planck found himself in the midst of a dilemma. His discovery challenged the entrenched beliefs of physics. Could light, which was understood as a wave, have a side that behaved like a particle? It was as if light had a double life, a kind of quantum superhero that could take on different forms. This idea generated great controversy and opened the door to a new way of understanding reality. In this context, Max Planck's dilemma was the catalyst for an intellectual revolution. The scientific community faced a difficult choice: to cling to traditional models or to open up to the idea that nature was full of surprises. The search for answers led many scientists to delve into a world where intuition often failed. The relationship between temperature and color became a symbol of how curiosity can challenge the status quo. Planck was not only seeking answers, but also establishing a new way of thinking about light and energy. His legacy is felt even in our daily lives, from the devices we use to the modern understanding of physics. Planck's story teaches us that science is not just a set of formulas and equations, but an adventure where each discovery can lead to more questions. What if, instead of viewing science as a series of answers, we considered it an endless quest for knowledge? This approach can transform the way we observe the world around us. Max Planck's dilemma is a reminder that even the most established truths can be challenged, and that intellectual curiosity is essential for the advancement of knowledge. In a sense, his story invites us to question our own understanding of the universe and to be open to new ideas, no matter how strange they may seem. The search for the relationship between temperature and color not only transformed physics but also showed us that at the heart of science, wonder and uncertainty are essential. Every time we turn on a light bulb, we are reminded that this seemingly simple light is the result of centuries of exploration and discovery. Thus, Planck's story becomes an intertwined thread in the vast tapestry of human knowledge. In the end, science is a journey that never ends. The questions arising from Planck's discoveries lead us to the next frontier of knowledge. What else awaits us in this vast and complex universe? Curiosity is our compass, and Max Planck's story is just the beginning of an exciting exploration. The connection between light and electricity is a mystery that has fascinated scientists and curious minds alike. How is it possible for a beam of light to trigger an electric current? To understand this, it is essential to delve into the concept of the photoelectric effect. This phenomenon was a true puzzle for many physicists in the early 20th century, challenging preconceived ideas about the nature of light. Imagine you are in a dark room and decide to turn on a lamp. As you do, light floods the space and suddenly everything comes to life. But what happens inside the lamp? Light is not just a wave traveling through the air. It has a more intriguing component. Light is made up of tiny particles called photons. These small entities are like little messengers carrying energy. This is where it gets interesting. When light strikes certain materials, especially metals, photons can collide with electrons on the surface of those materials. If a photon has enough energy, it can free an electron from the metal, thus generating an electric current. This is not only fascinating, but also marked a turning point in our understanding of physics. What does this mean for our view of light? By the late 19th and early 20th centuries, the wave theory of light was well established. However, the discovery of the photoelectric effect posed a dilemma. If light was just a wave, how could it free electrons? Wasn't it supposed that waves could not have such direct interaction? This is where a young physicist named Albert Einstein entered the scene, whose work would forever change the way we understand light. Einstein proposed that light could behave both as a wave and as a particle. This idea, known as wave-particle duality, was revolutionary. Imagine that light is like a wave in the ocean, but it can also be a billiard ball colliding with another ball. This duality became a key concept in quantum mechanics. And what was the reaction of the scientific community to these ideas? Many were skeptical. However, experiments began to validate Einstein's theories. As more research was conducted, it became clear that light had properties of both waves and particles, challenging our traditional understanding of physics. This led to a revolution in the way scientists thought about the universe. The connection between light and electricity also prompts us to reflect on how we interact with the world. Every time we turn on a light, we are harnessing the photoelectric effect. But what implications does this have for modern technology? From the invention of the light bulb to the devices we use today, the photoelectric effect has been fundamental in creating a wide range of technologies, such as solar panels and digital cameras. Think about a solar panel. When sunlight strikes the photovoltaic cells, photons release electrons, generating electricity. This process is a perfect example of how science can transform our daily lives. What began as an experiment in a laboratory has become a crucial source of renewable energy. Curiosity is not limited to scientists. We are all intrinsically connected to light. When we look at the sky and see the sun shining, we are witnessing the same energy that powers our devices. Every time we feel the warmth of the sun on our skin, we are experiencing a direct connection to the photoelectric effect. However, this connection goes beyond the physical. It leads us to question the nature of reality itself. If light can act as both a particle and a wave, what else in our universe has a similar duality? Could it be that many of the things we take for granted are more complex than they appear? As we explore the world of light and electricity, we venture into a territory where science and philosophy meet. The photoelectric effect is not just a physical phenomenon. It is a reminder that reality is often stranger than we can imagine. It invites us to look beyond the obvious and consider the multiple layers of meaning in everything around us. So the next time you turn on a light, remember that a tiny photon may have freed an electron, triggering an electric current that illuminates your world. Science in its purest essence is a journey of constant discovery, where each answer generates new questions and each phenomenon brings us a little closer to understanding the vast universe we inhabit. Light is a fascinating phenomenon, a thread that connects the world of physics with our everyday lives. Have you ever thought about how something as simple as light can have such a profound impact on our understanding of the universe? Light, in its purest essence, is both a wave and a particle. But how is it possible for something to be two things at once? The answer lies in the intriguing duality of light, a concept that revolutionized physics as we knew it. Since time immemorial, scientists have tried to unravel the mystery of light. At the beginning of the 20th century, a figure emerged who would forever change our perception of this phenomenon: Albert Einstein. His work not only challenged the beliefs of the time, but also laid the groundwork for what we now know as quantum mechanics. But what led Einstein to this astonishing conclusion? The answer is in the very nature of light. Light can be seen as a wave traveling through space, like the ripples in a pond when you throw a stone. However, it can also behave like a set of tiny particles called photons. How is it possible for the same entity to manifest in such different ways? The answer lies in the strange and wonderful world of quantum mechanics, where the rules of the game are much more complex and surprising than we could imagine. Einstein, while studying the photoelectric effect, realized that light, when absorbed by a material, could release electrons. This phenomenon could not be explained if we considered light only as a wave. Isn't it curious to think that this simple observation led Einstein to win the Nobel Prize? From that point on, science had to reconsider its approach to the nature of light. The question everyone was asking at that time was, how could something be both a wave and a particle at the same time? The answer to this enigma leads to one of the most intriguing concepts in quantum mechanics: wave-particle duality. Imagine you are at a concert, enjoying the music. When you close your eyes, do you feel that the music is a wave traveling through the air? Of course, but you can also think of the sounds as individual notes, each with its own character. Light is similar. It can be seen as a wave propagating, but also as a collection of tiny particles interacting with the world in a tangible way. This concept was a true turning point in science. It not only allowed us to better understand light, but also opened the door to new questions about the nature of reality. What does it really mean to observe something? Does our perception influence the nature of the observed object? These are questions that still dazzle us and lead us to question our own existence. The journey of light does not stop there. Understanding wave-particle duality led to the idea that everything in the quantum world is interconnected. Every particle, every photon exhibits behavior that challenges our classical notions. Have you ever wondered how it is possible that the universe is full of these surprises? The answer lies in the laws of quantum mechanics that govern the behavior of particles at microscopic levels. The legacy of Einstein and his contemporaries not only transformed physics, but also sowed the seeds of modern technology. Did you know that many of the technologies we use today, such as lasers and semiconductors, are based on quantum principles? Light, in its purest form, has become an unwavering ally in our quest for knowledge and understanding. The question that arises from all this is, what else does quantum mechanics have in store for us? As scientists continue to explore this fascinating field, we discover that the duality of light is not just a phenomenon, but a window into a universe full of possibilities. The implications of this duality go beyond physics. They affect our understanding of life itself and how we interact with the world around us. The duality of light is ultimately a metaphor for life. It reminds us that things are not always what they seem and that reality can be much more complex than our intuition suggests. In this vast cosmos, where the rules of the game are different, We find unexpected beauty in the complexity of the simple. So the next time you see a light shining, remember that you are contemplating a phenomenon that has changed the course of science. Light, with its duality, invites us to question, to explore, and to marvel at the complexity of the universe. In this dance between wave and particle, we find a reflection of our own existence where questions are as important as answers. The idea that electrons can behave as both particles and waves at the same time is so fascinating that it seems straight out of a science fiction story. But how did science arrive at this astonishing conclusion? The answer lies in an experiment that has challenged our understanding of the universe, the double-slit experiment. This experiment, simple in its design, reveals deep secrets about the nature of quantum reality. Imagine a scenario where you throw a small object like a ball at a wall that has two slits. If the ball is a particle, you would expect it to pass through one of the slits and form an impact pattern on the wall behind the slit. But what would happen if, instead of a ball, you threw electrons? This is where the story becomes intriguing. When the double-slit experiment is conducted with electrons, the result is much more perplexing than one might expect. At first, scientists thought that electrons, like balls, should pass through one of the slits. However, upon analyzing the results, they discovered that the electrons created an interference pattern on the wall behind, as if they were waves in a pond. This means that somehow the electrons were passing through both slits at the same time. But how is it possible that something so small and seemingly solid can behave like a wave? The plot thickens even further when scientists decide to observe the experiment. When a detector is placed at one of the slits to see which one the electron passes through, the interference pattern disappears. Now the electrons behave like particles, passing through only one slit and leaving a corresponding impact pattern. What does this mean? The simple act of observation seems to change the behavior of these tiny electrons. This puzzling phenomenon has led to many questions about the nature of reality. Is it possible that observation itself influences the quantum world? Imagine you are in a movie theater and decide to look away at the exact moment a key scene unfolds. Your decision to look or not could change the outcome of the movie. In the quantum world, it seems that observation can be so powerful that it can alter the result of an experiment. The duality of particles and waves raises questions about how we perceive reality. If electrons can be both particles and waves, what does that mean for us? The way we understand the world around us is challenged by this revelation. It leads us to consider the possibility that reality may not be as fixed as we believe, but rather in constant flux and dependent on our interaction with it. The interpretation of these findings has also sparked passionate debates among scientists, especially between Albert Einstein and Niels Bohr. Einstein, known for his deterministic approach, resisted accepting that uncertainty and chance played a fundamental role in physics. Bohr, on the other hand, argued that the quantum nature of reality implied that we could not know all aspects of a system at the same time. This controversy, known as the Einstein-Bohr debate, remains a topic of discussion in modern physics. However, what makes the double-slit experiment even more fascinating is its connection to the concept of quantum entanglement. Imagine you have two entangled electrons. This means that no matter how far apart they are, any change in one will instantaneously affect the other. It's as if they have a secret connection that allows them to communicate across unimaginable distances. This phenomenon challenges our classical notions of distance and separateness. As we delve deeper into quantum mechanics, we realize that the double-slit experiment is not just a laboratory experiment, but a window into understanding reality itself. It invites us to rethink our assumptions and consider that the universe could be much stranger than we ever imagined. The duality of light and particles leads us to reflect on the very nature of existence. The importance of this experiment lies not only in its theoretical implications, but also in its practical relevance in modern technology. From quantum computing to quantum cryptography, the concepts emerging from quantum mechanics are shaping the future of science and technology. Although the behavior of electrons may seem confusing, their study has led to advancements that are transforming our lives. The wonder of the double-slit experiment reminds us that the universe is a place full of mysteries. It challenges us to embrace uncertainty and explore the unknown. What other secrets lie hidden in quantum mechanics? As we continue our quest for answers, it is important to keep an open mind and be willing to question what we think we know. After all, at the heart of science, curiosity is what drives knowledge. Ultimately, the double-slit experiment not only teaches us about the nature of light and particles, but also invites us to explore the boundaries of our understanding and recognize that sometimes reality can be stranger and more wonderful than we could have ever imagined. Can simple observation change the essence of something? This is one of the most intriguing questions posed by quantum mechanics and, in particular, the Copenhagen interpretation. Unraveling this concept may seem like a journey into a fantasy world, but in reality, it leads us to the foundations of how we understand reality itself. In this context, the figure of Albert Einstein and his famous debate with Niels Bohr becomes a fascinating narrative about the nature of the universe. Einstein, a man of certainties, firmly believed that reality existed independently of our observation. To him, the world was like a clock, a mechanism that functioned precisely and predictably, regardless of whether someone was watching it or not. However, Bohr had a different view. For him, quantum reality was more like a movie in which observation becomes a crucial element of the plot. What would happen if, by looking, we caused a change in what is happening? Einstein's famous phrase, "God does not play dice," summarizes his resistance to the idea that reality could be influenced by observation. In contrast, Bohr argued that in the quantum world, what we see is only part of a more complex whole. Imagine trying to watch a movie, but every time you look at the screen, the ending changes. How could you understand the story if each observer has a different version of the events? This dilemma becomes even more intriguing when we consider the double-slit experiment. In this experiment, a stream of particles, such as electrons, is passed through two slits. If we do not observe, the particles behave like waves, creating an interference pattern on the screen behind. But if we decide to observe which slit each electron passes through, the interference pattern disappears, and the particles behave as if they were simply small balls. How can it be that the simple decision to observe changes the behavior of the particles? The Copenhagen interpretation leads us to consider the idea that quantum reality is not fixed. In this sense, observation not only reveals what is there, but can also influence what happens. But does this really mean that each of us creates our own reality? The answer is more complicated than it seems. Quantum reality is a territory where the rules of classical logic cease to apply, and that can be disconcerting. Are we facing a kind of quantum magic in trying to unravel the mysteries of quantum mechanics? Some feel as if they are exploring a fantasy world. However, this magical world has very real repercussions in science and technology. Quantum mechanics has led to advancements such as quantum computing and quantum cryptography, technologies that could revolutionize our lives. The debate between Einstein and Bohr was not just a clash of personalities, but a dialogue between two worldviews. Bohr, with his more flexible and probabilistic approach, became the defender of the Copenhagen interpretation. Meanwhile, Einstein, with his analytical mind, opposed the idea that chance could play a fundamental role in the universe. This conflict remains relevant today, and scientists continue to explore its implications. Could we be caught in a quantum dilemma? The tension between observation and reality leads us to question how we perceive the world around us. Every time we look at something, are we altering its essence? Science tells us yes. The Copenhagen interpretation invites us to consider that our perception is not just passive but active and contributes to the creation of what we know as reality. It is fascinating to think that at fundamental levels, the universe might be more interconnected than we imagine. Observation is not simply an act of looking, it is an act that can shape the very essence of matter. And this leads us to a troubling question. If our actions and decisions can influence reality, what does that mean for our everyday experience? In summary, the Copenhagen interpretation has opened a path toward a new understanding of reality. It invites us to reflect on the role that observation plays in our daily lives and how sometimes the simple act of looking can become an act of creation. The struggle between Einstein and Bohr is not just a battle between two great minds, but a mirror reflecting our own struggles to understand the world around us. So the next time you face a dilemma, ask yourself, is your perception altering reality? Perhaps deep down, we are all observers in this vast and enigmatic universe. The quest to understand quantum mechanics remains alive, and every answer we find raises new questions, and so the journey through science continues. What if I told you that there is a phenomenon in the universe that challenges our understanding of distance and connection? Imagine two particles that, although separated by thousands of kilometers, can instantaneously influence each other. This phenomenon is called quantum entanglement, and it is one of the most fascinating and perplexing features of quantum mechanics. When we think about the world around us, we often assume that things are separated by space. A ball thrown into the air does not affect an object on the other side of the room, right? But quantum entanglement challenges that notion. Two entangled particles act as if they are connected by an invisible thread, such that what happens to one immediately affects the other, regardless of the distance between them. How can this be possible? To understand it, let's think about a pair of gloves. If you find a left glove in one place and a right glove in another, you know they are part of the same pair, even if they are kilometers apart. However, in the quantum world, particles do not have a defined identity until they are observed. It's as if those gloves could change their shape the moment you look at them, revealing their true nature. This phenomenon was first described by Albert Einstein, who called it spooky action at a distance. Einstein was so perplexed by entanglement that he could not accept it as a real aspect of nature. He believed there must be a deeper explanation, one that did not involve instantaneous connection. But later experiments have shown that entanglement is a fact, not just a theoretical curiosity. In a classic entanglement experiment, two particles are created together and then separated. When we measure the state of one of them, we instantly know the state of the other, even if it is light years away. Can you imagine being able to communicate instantaneously with someone in another galaxy? This phenomenon has led scientists to explore new possibilities in quantum computing and cryptography. But what does this mean for our understanding of reality? If information can be transferred instantaneously between particles, does that mean that time and space are not as absolute as we thought? Some scientists suggest that entanglement could indicate that reality is more interconnected than we imagine. Perhaps we are not as separated as we believe. In everyday life, we are used to thinking of things as individual entities. However, quantum entanglement invites us to consider a more holistic view of the universe. Perhaps all particles are entangled in some way, forming an interconnected web that transcends our classical understanding. What implications would this have for our perception of life and consciousness? The idea that particles can be entangled has repercussions in many fields, from physics to philosophy. Could quantum entanglement have something to do with our emotional connection to others? We might imagine that our relationships are intertwined in a way that goes beyond the physical. Quantum science pushes us to question what we know and to open our minds to new possibilities. Research on entanglement is not only intriguing but also at the forefront of technology. Advances in quantum computing, which rely on entanglement, promise to revolutionize the way we process information. Imagine computers that can solve complex problems in an instant, opening a new world of possibilities in artificial intelligence and the simulation of complex systems. However, the nature of entanglement also raises ethical questions. If we can communicate information instantaneously, how do we ensure it is used responsibly? Are we ready to understand and manage the power that comes with this knowledge? Science, in its quest to unravel the secrets of the universe, also invites us to reflect on the implications of what we discover as we move toward a future where quantum mechanics could become an integral part of our daily lives. The idea of entanglement reminds us that the universe is a mysterious and complex place. It challenges us to reimagine what we know about connection and distance. In this vast cosmos, we might be more entangled than we ever thought. And perhaps that is part of the beauty and magic of existence. Quantum entanglement offers us a new way of looking at the world, inviting us to consider that the boundaries we set might be more flexible than we believe. On this journey through science, we find ourselves at a point where curiosity and wonder intertwine, opening the door to a future full of astonishing discoveries. So the next time you think about distance, remember that, at the most fundamental level, everything is connected, and that is just the beginning of what quantum mechanics has to offer. Have you ever wondered what reality really means? For decades, scientists have tried to unravel this mystery, and one of the most intriguing milestones in this quest has been Bell's theorem. This theory serves as a bridge between quantum mechanics and our everyday understanding of the world. But what exactly is Bell's theorem, and why is it so significant? Imagine you have a pair of gloves, one right and one left, and you place them in two different boxes. Then you send each box to two friends who are miles apart. If one of them opens their box and finds the right glove, they immediately know that the other friend has the left glove. This seems obvious, but in the quantum world, things are not so simple. Bell's theorem is based on a concept called non-locality. This means that, at the quantum level, particles can be connected in such a way that the state of one particle can instantaneously influence the state of another, regardless of the distance separating them. How is this possible? Bell's theorem suggests that if quantum mechanics is correct, then we must accept that there is something in nature that challenges our classical notions of cause and effect. Over the years, many physicists have attempted to prove or refute the predictions of Bell's theorem, but why is it so complicated? Because quantum mechanics at its core does not behave as we are accustomed to. Instead of following fixed rules, particles behave probabilistically. This suggests that what we consider real may only be an illusion, an interpretation of a much more complex reality. Experiments designed to test Bell's theorem have been set up to demonstrate whether particles can be entangled, meaning connected in such a way that the state of one affects the other, even over great distances. Isn't it astonishing to think that two particles can communicate instantaneously like a pair of friends sending telepathic messages? However, this phenomenon does not seem to have a simple explanation in our everyday world. But what about the results of those experiments? In the 1970s, a group of scientists conducted tests that seemed to confirm the predictions of Bell's theorem. The results showed that the particles were indeed entangled, and that their properties were correlated in ways that defied classical logic. This indicated that there was something more at play, something we could not see or fully understand. Some critics have argued that these results could be explained by alternative theories, leading to intense debate among physicists. The question everyone is asking is, how far does our understanding of reality extend? Some believe that Bell's theorem suggests our perception of the world is limited, that there are additional dimensions of existence that we simply cannot perceive. The idea that our observations can affect quantum reality suggests that consciousness plays a fundamental role in creating what we consider true. Is it possible that the human mind in some way influences the universe? Perhaps we are not as separate from what we observe as we think. This concept has led to fascinating speculations about the nature of reality and consciousness. In a world where distance seems to matter little, quantum entanglement invites us to reconsider our notions of connection. What does it really mean to be interconnected? In this sense, Bell's theorem is not only a milestone in physics, but also raises profound philosophical questions. It makes us question our perception of individuality and separation. As we advance in research, it becomes clear that Bell's theorem is not just a scientific curiosity, but a window into a deeper understanding of the universe. It prompts us to rethink our preconceived ideas about time, space, and causality. Each new discovery in this area brings us one step closer to understanding what it truly means to exist in this vast cosmos. We can see how Bell's theorem has influenced not only modern physics, but also the way we approach questions about existence and reality. Debates about the nature of quantum entanglement have inspired philosophers, writers, and artists, creating a dialogue between science and culture. In this sense, Bell's theorem is a powerful reminder that science and art can intertwine in their quest for meaning. As technology advances and experiments become more sophisticated, we are likely to continue discovering more about the nature of quantum reality. Perhaps one day we will fully understand entanglement and non-locality, but for now, Bell's theorem remains an enigma that challenges us to think beyond what we see. Ultimately, Bell's theorem not only offers us a new way of viewing the universe, but also reminds us that there is much more to discover. Questions about reality and consciousness will continue to inspire future generations of scientists and thinkers as we seek to unravel the secrets of the cosmos. So the next time you look up at the starry sky, remember that every star, every particle is connected in ways we are just beginning to understand. The theories and concepts surrounding quantum mechanics may seem like a labyrinth of complex ideas, but what if I told you that, at its core, it all boils down to a simple game of connections? In the 1970s, a group of physicists in Berkeley set out to test Bell's theorem, a proposal that promised to shed light on the enigma of quantum reality. But how dare they challenge what we thought we knew about the universe? Imagine for a moment that you have a coin. If you flip it, it could land on heads or tails, right? Now think of quantum mechanics as if it were a magical coin. Instead of deciding between heads or tails, this coin can be in both states at once until someone observes it. This is how Bell's theorem challenges our most fundamental notions of how the world works. Is this phenomenon merely an illusion, or is there something deeper at play? The experiments conducted in Berkeley were like a treasure hunt in the quantum world. The scientists aimed to test whether particles could be entangled, sharing information instantaneously regardless of the distance separating them. Imagine you have two friends who, no matter how far apart they are, always know what the other is thinking. Wouldn't that be amazing? This quantum entanglement suggests that, at a fundamental level, the universe is much more interconnected than we ever imagined. The physicists in Berkeley used an ingenious approach to test Bell's theorem. Instead of simply looking at the particles individually, they decided to observe how they behaved in pairs. By doing so, they began to notice something surprising. Their results could not be explained by classical physics. How is it possible that these particles seem to communicate with each other across empty space? What does this mean for our understanding of reality? The atmosphere in Berkeley during those years was as vibrant and full of creativity as the experiments themselves. It was the era of counterculture, a time when revolutionary ideas were in the air and science intertwined with art and philosophy. Scientists felt like artists creating masterpieces in the form of equations and experiments. Could it be that the art of science and the music of life came together to reveal the secrets of the universe? Some of these experiments involved the use of lasers and particle detectors that recorded the interactions of light. Every time a measurement was made, the results seemed to defy expectations. Could these measurements simply be a product of chance? Or was there a deeper and more mysterious connection guiding the behavior of these particles? The question of whether the particles were truly interconnected or simply behaving in a way that suggested they were was a topic of intense debate. Some physicists, like Einstein himself, could not accept the idea that reality could be so strange. They wondered, does God play dice with the universe? The answer to this question remains a mystery. But what is clear is that every experiment conducted in Berkeley left an indelible mark on our understanding of quantum mechanics. The tests conducted by the physicists in Berkeley not only confirmed Bell's theorem, but also opened the door to a new understanding of the universe. Each measurement, each result, was like an echo resonating in the halls of science, challenging traditional notions and pushing the boundaries of what we believed possible. The connection between science and society also became evident. Quantum experiments were not just a quest for truth, they also reflected the spirit of a generation questioning established norms. quantum mechanics became a symbol of the search for freedom and authenticity in a world that often seemed governed by strict and limiting rules. Could it be that science, in its essence, is destined to empower our curiosity and creativity? Ultimately, the results of these experiments led to profound reflection on the nature of reality. If quantum entanglement is a fundamental truth, then what does that mean for our understanding of ourselves and our place in the universe? The idea that we are all connected in some way resonates with many philosophies and beliefs throughout history. Is there hidden wisdom in this entanglement? In conclusion, the research conducted in Berkeley not only challenged notions of classical physics, but also invited us to rethink our relationship with the universe. By exploring Bell's theorem and quantum entanglement, we delve into a space where science, philosophy, and art converge. Who knows what other secrets await us in the vast ocean of quantum mechanics, waiting to be discovered by the curious minds of future generations? What would happen if I told you that two particles can be connected in a way that challenges everything we know about space and time? The story we are going to explore revolves around the experiments conducted by two brilliant physicists, John Clauser and Alain Aspect, who tested Bell's theorem. This theory invites us to look at the quantum world in a completely new way, where distance is not an obstacle and the connection between particles can be instantaneous. Imagine a pair of gloves, one left and one right. If you separate them by thousands of kilometers and open one, you will instantly know the shape of the other. This is a simple example that helps us understand quantum entanglement, a phenomenon where particles that have been in contact can continue to communicate across unimaginable distances. But how can they do this? The answer lies in the very nature of reality, a mystery that Clauser and Aspect set out to unravel. During the 1970s, Clauser conducted an innovative experiment in Berkeley, California. His goal was to test one of the most controversial claims of Bell's theorem, that entangled particles can influence each other regardless of the distance. Can you imagine the excitement and tension in the air as he prepared to carry out this test? It was a crucial moment that could change our understanding of physics forever. Clauser's experiments involved measuring the properties of pairs of entangled particles. At one moment, one particle could be measured in a particular state, and its twin, even if it were kilometers away, should show the same state. But what was truly astonishing was that upon measuring one of the particles, the other seemed to know immediately what had happened. How is it possible for this information to be transmitted instantaneously, even faster than light? The surprise came when the results of Clauser's experiments began to align with the predictions of quantum mechanics. This meant that reality was not as clear and straightforward as many had thought. In a world where everything seems to have a cause and an effect, quantum particles behaved in strange and perplexing ways. What implications would this have for our understanding of the universe? In 1982, Alain Aspect conducted even more sophisticated experiments that confirmed Clauser's findings. He used more advanced techniques and managed to reduce potential errors in the measurements. His work not only validated Bell's theorem, but also opened the door to a new field of study, quantum computing. But what does this really mean for us as human beings? The ability of quantum entanglement not only challenges our notions of distance and time, but also raises profound philosophical questions. If two particles can be connected instantaneously across the void of space, what does this mean for reality itself? Is the world as interconnected as quantum mechanics suggests? The results of these experiments not only revolutionized physics, but also influenced the realm of philosophy. Some argue that quantum entanglement suggests that reality is more unified than we think, while others believe this could open the door to new theories about the nature of consciousness. Could quantum mechanics offer answers to questions that have long intrigued humanity? Moreover, quantum entanglement has practical applications in modern technology. From the creation of quantum computers that could solve complex problems in record time to quantum cryptography, which promises a completely new way to transmit information securely. Isn't it fascinating to think that the very nature that seems to defy our intuitions could be the key to future innovations? As we reflect on the work of Clauser and Aspect, we not only observe an advance in physics, but also a shift in our way of thinking about the world. The idea that particles can be entangled in ways we cannot see or understand invites us to question our beliefs about separation and individuality. Could it be that at a fundamental level we are all more connected than we imagine? Each discovery in this field not only adds a piece to the quantum puzzle, but also reminds us that there is still much to explore. The very essence of quantum mechanics challenges us to keep investigating, to not settle for what we already know, and to open our minds to new possibilities. What other wonders await us in the vast and mysterious infinity of the universe? As we embark on this journey through the complexities of quantum mechanics, it is crucial to maintain curiosity and wonder. Science is a journey, and every question that arises is an invitation to keep exploring. So the next time you look up at the starry sky or think about the nature of the universe, remember that there are still secrets to uncover, mysteries waiting to be revealed, and connections that transcend time and space. The adventure is just beginning. What if I told you that birds, those beings we see flying through the skies, use quantum mechanics to navigate during their migrations? It's fascinating, isn't it? Every year, millions of birds embark on epic journeys that span thousands of kilometers, and they do so with astonishing precision. But how do they manage to find their way in the vastness of the sky? One of the secrets to their extraordinary ability lies in a protein called cryptochrome. This protein, present in the retinas of birds, is sensitive to light and plays a crucial role in their sense of orientation. When sunlight hits the cryptochromes, chemical reactions occur that allow birds to see the Earth's magnetic field. It sounds like something out of a science fiction movie, but it's pure science. Imagine walking into a dark room and suddenly a dim light illuminates the space. That light not only allows you to see objects, but also helps you understand where you are. Birds do something similar, but their light is the sun, and their understanding of the environment is based on a quantum phenomenon. The key lies in how cryptochromes interact with light. When a photon, which is a particle of light, strikes the cryptochrome, it undergoes a transformation. From that interaction, pairs of electrons are formed that are quantum entangled. This means that even though the electrons are separated, the information about their state is interconnected instantly. It's as if they have a direct line between them, an instant connection that allows them to communicate regardless of distance. So, what does this imply for birds? Through this quantum entanglement, birds can interpret information from the Earth's magnetic field and use it to navigate. It's as if they have an internal GPS that allows them to know their position in relation to magnetic north. This sense helps them navigate with incredible precision, even in adverse weather conditions and unfamiliar territories. Throughout evolution, this sense has been crucial for the survival of many bird species. Migrations are not just a journey, they are a necessity that allows them to find food, reproduce, and escape extreme weather conditions. The ability to orient themselves accurately has been a vital selective trait, and quantum mechanics has played a fundamental role in it. But what if we shift our perspective? Could this imply that we, humans, also have hidden abilities influenced by quantum mechanics? While we are still far from fully understanding the extent of quantum influence in our lives, scientists are beginning to explore how these principles could apply to other organisms, including humans. Imagine what it would be like if we could use quantum mechanics to enhance our own perception of the world. The idea that something as small as a cryptochrome could have such significant effects may seem incredible, but it reminds us that nature always finds surprising ways to solve complex problems. On the other hand, this phenomenon also leads us to reflect on the interconnectedness of all living beings. Birds, through their migration, not only follow fixed routes but also form part of a larger web in the ecosystem. Their movements affect other species, and their ability to navigate can influence the balance of life on Earth. In this sense, quantum mechanics speaks not only of particles and waves, but also offers a new way of viewing the world. It invites us to think about how we interact with our environment and how our actions can have impacts beyond what we can see. As we discover more about how quantum mechanics influences biology, we find ourselves on the cusp of a new scientific revolution. Birds are just one example of how these principles may be at play in nature. If bird migration is based on quantum physics, what other secrets might nature reveal that we have yet to uncover? So the next time you see a bird flying in the sky, remember that behind that seemingly simple image lies a world of incredible science. Quantum mechanics is not just an abstract concept, it is present in everyday life, connecting all living beings in ways we are just beginning to understand. And so, the journey of birds leads us to reflect on our own place in the universe. What other wonders await us? What other mysteries of nature might be revealed through the lens of quantum science? The search for answers continues, inviting us to explore the unknown with wonder and curiosity. Have you ever marveled at the complexity of the scents that surround us? From the aroma of freshly brewed coffee in the morning to the fragrance of a flower in full spring, our ability to perceive smells is one of the wonders of biology. But did you know that quantum mechanics might play a surprising role in how we experience these scents? This phenomenon leads us to explore a fascinating field that unites physics with biology, quantum biology. The perception of smell begins with molecules that are released from an object. These molecules travel through the air and enter our nostrils, where they encounter olfactory receptors in our cells. But why are these molecules capable of provoking a sensation in our brain? This is where quantum mechanics comes into play. Imagine that each scent molecule is like a little messenger that must make a journey through a sea of atoms and molecules. Sometimes these messengers need a little push to reach their destination. Quantum mechanics suggests that, at very small levels, particles do not behave in the traditional way we know. Instead of following a clear path, they can exist in multiple states at once. This may seem strange, but in the quantum world, it is more than normal. So what happens when a scent molecule reaches an olfactory receptor? This is where it gets fascinating. Scientists have proposed that scent molecules can use a quantum process called quantum tunneling to cross energy barriers. Imagine you are trying to jump over a tall fence. Classical mechanics would say you need enough energy to jump over it. However, in the quantum world, you could simply appear on the other side without having jumped at all. This phenomenon could allow scent molecules to bind to their receptors more efficiently. This quantum tunneling is not just an abstract concept. Some studies suggest that this mechanism may explain why we can detect scents at such low concentrations. In other words, thanks to quantum mechanics, our sense of smell could be much more precise than we think. But how does this relate to our daily experience? When we smell something, our reaction is not just physical. It is also emotional. Scents can evoke memories, sensations, and moods. Quantum mechanics, by influencing how we perceive these smells, could be connecting the fragrance of a flower with a childhood memory. Isn't it fascinating to think that a physical phenomenon at the smallest level can have such a big impact on our emotions? Moreover, this opens a new field of research on how scents can affect our decisions and behaviors. Could it be that the chemistry of an aroma, manipulated by quantum mechanics, influences our choice of partner or our preference for certain foods? This is an area that scientists are beginning to explore, and the implications are enormous. Imagine a world where understanding how scents work at a quantum level could help us create perfumes that not only smell good, but also positively influence our emotions. Quantum biology is not only changing our perception of chemistry, but also transforming our understanding of the connection between body and mind. As we advance in our understanding of quantum biology, the question of how the quantum world affects everyday life becomes increasingly relevant. The idea that our sensory experiences may be influenced by the laws of physics is a powerful concept. It leads us to reconsider how we understand not only scents but also other sensory experiences. Quantum mechanics is not just a topic of interest for physicists and mathematicians, it is a concept that can help us better understand human nature. In this sense, quantum biology becomes a thread that connects science with human experience. It invites us to explore not only how we function, but also why we feel the way we feel. As we continue to uncover the mysteries of quantum mechanics, it is essential to remember that each discovery brings us a little closer to unraveling the complexity of the universe and, at the same time, of ourselves. The connection between physics and biology is a reminder that, although there is a vast array of phenomena surrounding us, they often intertwine in unexpected ways. In conclusion, by exploring how quantum mechanics can influence our perception of smell, we are not only opening a door to science, but also to a greater understanding of our own humanity. The next time you take a deep breath and enjoy the aroma of your coffee or a rosé, remember that there is a quantum world working in the background, making that experience possible. What other secrets will quantum biology reveal to us in the future? Science is constantly evolving, and so are we, just like the aromas that envelop us. Metamorphosis is a fascinating phenomenon that shows us how life can transform in ways that often seem straight out of a fairy tale. Let's think about the tadpole, a small creature that begins its life in water, with a body that swims and breathes through gills. But how is it possible for this little being to become a frog, an animal that jumps and breathes air? The answer to this transformation may be more related to quantum mechanics than we could imagine. As a tadpole develops, it goes through several stages in its life. From its beginning as an egg to its transformation into an adult frog, each phase is carefully orchestrated. However, this is where the story becomes interesting. Quantum mechanics, that strange and fascinating field of physics, may be influencing this biological process. But how can something so abstract affect such a concrete creature? The answer lies in the way the cells of the tadpole communicate and cooperate with each other during its metamorphosis. It has been discovered that, at the quantum level, particles can behave unexpectedly, interacting in ways that cannot be explained by classical physics. This means that cells are not just reacting to physical or chemical stimuli. They may also be using quantum principles to coordinate their activity. Isn't it amazing to think that there is a quantum dance at the heart of this process? The way cells communicate during the metamorphosis of the tadpole resembles an orchestra. Each cell has its own role, but for the symphony to work, they all must be in harmony. If one cell receives a signal, it can decide to act in a way that affects other cells, which in turn may do the same. This type of communication is not only crucial for the development of a tadpole, but it has also been suggested that it may be related to quantum phenomena that allow information to be shared instantaneously and efficiently. Scientists have begun to wonder whether the quantum processes occurring in the cells of tadpoles reflect the more fundamental nature of life itself. Could it be that life, in its essence, is governed by quantum rules that we have not yet fully discovered? This kind of questioning leads us to explore not only the development of tadpoles, but also the very fabric of biology. When we think about metamorphosis, it is also interesting to consider how these quantum principles might apply to other living beings. What if the same transformation process we see in a tadpole is found in other species? Imagine a butterfly emerging from its chrysalis. Just like in the case of tadpoles, its transformation is an impressive spectacle. Could it be that butterflies are also using quantum mechanics in their development? As scientists investigate more about quantum biology, they are realizing that the implications of these discoveries could be much broader than we think. For example, it has been suggested that quantum mechanics could be behind some of the most essential processes of life, such as photosynthesis, where plants convert sunlight into energy. If quantum principles can influence how a tadpole becomes a frog, what other wonders might be revealed? The metamorphosis of the tadpole is more than just a simple physical change. It is a journey that reflects the complexity and beauty of life. Imagine for a moment that every cell in your body is in constant communication with the others, using quantum principles to coordinate their activity. This idea may seem strange, but more and more research suggests that we are just scratching the surface of what it means to be alive. The implications of quantum biology are vast and exciting. What if the key to understanding how species develop and evolve lies in these quantum phenomena? It could be that the mysteries of life are not only found in the laws of genetics, but also in the strange behaviors of subatomic particles. Perhaps metamorphosis is not just a change in form, but a reminder that life itself is a dynamic process full of surprises. As we continue to explore these ideas, it is vital to keep an open mind. Science often challenges our most basic assumptions and invites us to reconsider what we think we know. The metamorphosis of the tadpole is a perfect example of how life can manifest in extraordinary ways and how quantum mechanics may be at the heart of that transformation. Therefore, when we observe a tadpole jumping in the water or a butterfly flying in a garden, let us remember that there is an invisible world at play, one where the rules of reality are more flexible than we think. Science is taking us on a journey that we have only just begun, and each discovery brings us a little closer to unraveling the mysteries of life and the universe. What other secrets might be waiting to be revealed in the amazing world of quantum biology? The answer to that question could change our understanding of life as we know it. Quantum biology is a fascinating field that explores how the principles of quantum mechanics, the same ones that govern the behavior of tiny particles, can influence biological processes on larger scales. Have you ever wondered how it is possible for living beings to perform such complex and precise functions? The answer, surprisingly, may lie in the quantum world. To understand this, let's think of a symphony orchestra. Each musician has a specific role, but the magic really happens when they all play together in harmony. In the biological world, molecules, which are like the musicians of the orchestra, interact with each other in ways that may seem chaotic, but actually follow very precise rules. Quantum mechanics provides the score that allows these molecules to work together efficiently and effectively. A clear example of this can be found in photosynthesis, the process that plants use to convert sunlight into energy. Imagine that sunlight is like a set of musical notes that plants must interpret. In this case, the leaves of the plants are the performers that, through quantum mechanics, manage to capture and utilize that energy in an extremely efficient manner. How do they do it? Through quantum phenomena, where electrons behave in surprising ways, allowing solar energy to be transferred from one molecule to another with almost no losses. Another curiosity is how migratory birds navigate during their long journeys. It has been discovered that some species use quantum mechanics to detect the Earth's magnetic field. This is like having an internal GPS that not only tells them where they are, but also where they need to go. All thanks to a small molecule in their eye that responds to light and the direction of the magnetic field. Isn't it amazing to think that a quantum phenomenon could be the key to the survival of these creatures? As we explore more about quantum biology, we find that even our own perceptions can be influenced by it. The sense of smell, for example, is an area where quantum mechanics could play a crucial role. When we smell something, our receptor molecules in the nose interact with odor molecules. Through a quantum process, our bodies can recognize these smells more accurately than if they simply depended on the physical shape of the molecules. This means that, in a sense, we are feeling the world through quantum principles. The metamorphosis of a tadpole into a frog is another fascinating example. During this process, the cells of the tadpole change drastically, and it is believed that quantum mechanics could be behind some of these transformations. The molecules in the cells must communicate with each other and make complex decisions about how they should grow and change. It's as if they have a conversation in a language that only they understand, and that language could be quantum. Quantum biology does not stop at the transformation of living beings, it also extends to evolution itself. Can you imagine that the genetic changes driving evolution could be influenced by quantum phenomena? This opens the door to the possibility that genetic variation, that spark of diversity that allows species to adapt and survive, is connected to quantum principles. Mutations, often seen as errors or failures in DNA, could be the result of quantum events that alter the molecules of genetic material. This concept challenges the way we normally think about biology and evolution. Instead of being a linear and predictable process, evolution could be more like a chaotic dance, where the rules of quantum mechanics influence every step. The quantum revolution in biology is changing our understanding of what it means to be alive. It is no longer sufficient to think of biology solely in terms of chemical reactions. We must now consider how quantum mechanics may be intertwined in those processes. This new perspective leads us to rethink many fundamental questions about life and the universe. What implications does this have for medicine, genetics, and biotechnology? As we delve deeper into quantum biology, we may discover new ways to treat diseases, improve crops, and even better understand our own place in the cosmos. Quantum biology is not just a field of study, it is an invitation to explore the unknown and expand our understanding of life itself. In summary, quantum biology shows us that the complexity of life is not just a biological phenomenon, but also a quantum phenomenon. From photosynthesis to the sense of smell, every corner of biology is imbued with mysteries that we are only now beginning to unravel. The next time you observe a tree, a migration of birds, or even stop to smell a flower, remember that in that moment, quantum mechanics could be playing a crucial role in the functioning of the life around us. This connection between the quantum world and the biological invites us to keep exploring, keep questioning, and keep marveling at the complexity of the universe. Photosynthesis is a fundamental process for life on Earth, but did you know there is something extraordinary about the way plants capture sunlight? Imagine for a moment a plant as a small factory that converts light into energy. However, this factory does not operate in a conventional manner. Instead of being a machine that follows strict rules, it uses principles of quantum mechanics to do its job more efficiently. Sunlight, that gift from the universe, reaches Earth in the form of tiny particles called photons. Just like a bouncing ball, photons travel through space, and when they reach a plant leaf, they can be captured. But what exactly happens in that magical moment? The plant has a special structure called chlorophyll, which acts like a magnet for these photons. But here comes the interesting part. Chlorophyll not only traps light, but it does so with astonishing efficiency thanks to quantum mechanics. How is it possible that plants are so efficient in this process? The answer lies in a quantum phenomenon called quantum coherence. Think of it like a perfectly synchronized orchestra. Instead of each musician playing their part independently, they all work together in harmony. Similarly, the electrons in chlorophyll behave as if they are linked together, allowing them to move quickly through the plant's structure and find the best route to transform light energy into chemical energy. What does this mean for us humans? It shows us that nature has perfected a method of energy capture that surpasses any technology we have developed so far. While our machines often lose energy in the form of heat, plants seem to have found a way to utilize almost all the light they receive. It's as if they have a secret that we have yet to discover. If you're wondering how the transition from light to chemical energy works, it's fascinating. When a photon hits a chlorophyll molecule, it elevates an electron to a higher energy level, as if giving it a push. This excited electron doesn't stay still. It travels through the plant, driving a series of chemical reactions that ultimately produce glucose and oxygen. But here's the trick. This process occurs at a surprising speed, thanks to that quantum coherence we mentioned earlier. Now imagine you are watching a relay race. Each runner passes the baton to the next perfectly, without losing time. That's how electrons are transferred from one molecule to another in plants. This speed and efficiency are vital, as sunlight is not available all the time. Plants have learned to make the most of every ray of sunshine, even in the most challenging conditions. However, the mystery doesn't end here. Quantum photosynthesis is not just a scientific curiosity. It also has enormous implications for our understanding of the world. If we could fully comprehend how plants achieve this feat, we could be inspired to create new technologies that mimic their processes. Can you imagine solar panels that capture light as efficiently as a leaf? It would be a radical change in our way of producing energy. Quantum biology is opening new doors in scientific research. As scientists study more about these processes, they are beginning to realize that quantum mechanics is not just a phenomenon that manifests in subatomic particles, but also plays a crucial role in more complex biological systems. This challenges our traditional notions of how life works and invites us to rethink our understanding of nature. Moreover, quantum photosynthesis leads us to reflect on interconnectedness in nature. Every plant, every tree, every leaf is part of an intricate system of life where energy flows and transforms. In this system, quantum mechanics acts as the thread that connects everything, from the smallest molecules to the vastest ecosystems. In this context, it is vital that we recognize the importance of caring for our environment. Plants not only provide us with oxygen and food, but they are also incredible examples of how nature uses quantum principles to thrive. Protecting them is protecting ourselves and ensuring that we continue to benefit from their amazing methods of energy production. Finally, quantum photosynthesis is not just a topic of study, but an invitation to explore the wonders of the universe. It reminds us that, although we often feel disconnected from nature, we are actually deeply intertwined with it. Every time we see a plant, we can remember that an extraordinary process is taking place, a quantum dance that sustains us all. Science, then, is not just a set of facts, but a continuous narrative that connects us with the cosmos and with life itself. Quantum mechanics, with its mysteries and wonders, is not limited to the small, the subatomic. Its impact extends to a field that, at first glance, might seem so distant from particles and waves, the evolution of species. Have you ever wondered how quantum physics could influence the development of life on Earth? It turns out that the connection is deeper than we imagine. Evolution, at its core, is a process of change and adaptation. Over millions of years, species have been evolving, mutating, and adapting to their environment. But what if I told you that the laws of quantum mechanics could play a crucial role in this process? The idea that small quantum fluctuations can influence genetic variation opens up a world of possibilities. Mutations, those small alterations in DNA that can give rise to new traits, have traditionally been seen as errors or accidents. However, some research suggests that certain quantum processes may facilitate these mutations, making evolution not just a game of chance, but a dance between the random and the ordered. How could this be possible? The answer lies in the very nature of particles and how they behave. In the quantum world, particles can exist in multiple states at once. Imagine flipping a coin, and instead of landing on heads or tails, it remains in a state of superposition where it can be both at the same time. This concept may seem strange, but it suggests that at the most fundamental level, nature is much more flexible than we think. Thus, some theories propose that this principle of superposition could be present in genetic mutations. The very structure of DNA, the instruction manual of life, could be influenced by these quantum fluctuations. In this sense, quantum mechanics not only becomes a spectacle for physicists, but also a key player in the drama of life. Imagine that every time a cell divides, there is a small quantum spark that can generate a variation in the DNA sequence. This spark could be the beginning of a new characteristic, a new trait that could give an organism an advantage in its environment. Moreover, quantum mechanics may influence how species interact with their environment. Organisms do not evolve in a vacuum. They are in constant interaction with other living beings and with the environment. The decisions and adaptations they make may be influenced by quantum factors. For example, under conditions of environmental pressure, small fluctuations in DNA could lead to a mutation that, although rare, might offer a survival advantage. What about genetic diversity? Quantum mechanics could be responsible for the richness of variations within a population. Instead of relying solely on natural selection and the accumulation of mutations over generations, we might consider that there is a quantum component that adds an element of surprise and creativity to the evolutionary process. This could explain why some species seem to undergo abrupt changes rather than gradual progress. But how can all this be tested? Research in quantum biology and evolution is in its early stages, but scientists are beginning to explore how these principles can be measured and observed in nature. The idea is that by understanding how quantum fluctuations can influence evolution, we could unravel some of the deepest mysteries of life itself. Imagine a future where we understand that life is not just a series of chemical reactions, but a phenomenon deeply influenced by the rules of the quantum universe. The implications of this are enormous. It would not only change our understanding of biology, but could also offer new perspectives on health, disease, and how we face the challenges presented by our environment. Evolution and quantum mechanics could be two sides of the same coin, united in a cosmic dance that has shaped all forms of life on Earth. As we delve deeper into this fascinating topic, we may begin to see life from a completely new perspective, where every small change, every mutation is not just an accident, but a manifestation of the most fundamental forces of the universe. In the end, the quantum revolution does not stop at particles and waves. It delves into the very heart of biology and evolution. It invites us to reconsider our relationship with life, with nature, and with the cosmos. The next time you observe an organism, remember that behind its existence there could be a quantum story, a narrative that connects physics with biology in ways we are just beginning to understand. Can we say that quantum mechanics plays a role in the evolution of species? For many, this question may seem absurd, as if we were searching for answers in a labyrinth of possibilities. However, as we delve into the world of quantum mutations, we begin to see that reality may be stranger than we imagine. Mutations are the engine of evolution, small changes in DNA that can lead to new characteristics in organisms. But what if those changes were not just the result of errors or adaptation to the environment, but also of quantum phenomena? Think of DNA as a recipe book. Each recipe is a gene, and mutations are like changes in those ingredients. But what if some of those changes occurred in unexpected and mysterious ways? A fascinating example of how quantum mechanics can influence mutations is the idea that subatomic particles can exist in multiple states at the same time, a property known as superposition. This can be compared to the idea that a coin tossed in the air is not just heads or tails, but in a sense can be both simultaneously until it lands and comes to a stop. Thus, in the quantum world, the possibilities are broader than classical logic would allow us to think. Now, how does this superposition translate into the biological world? Some theories suggest that during DNA replication, subatomic particles may influence the nitrogen bases that form the genetic code. This process could lead to unexpected mutations that, under certain circumstances, could be beneficial for an organism. Like an artist who, by mixing colors, creates an unexpected shade that turns out to be a masterpiece, quantum mechanics could be contributing its own palette to evolution. It is intriguing to think that the changes that give rise to new species might not be merely accidental, but could also be influenced by the probabilistic nature of the quantum. Who would have thought that the same principles that govern the behavior of subatomic particles could impact the biological diversity we see on Earth? The connection between quantum mechanics and biology opens a new horizon, where the rules are more flexible and the possibilities are infinite. Let's consider the implications of this. If quantum mutations are real, then the process of evolution could be faster and more dynamic than we have believed. Imagine a species that, instead of waiting millions of years to adapt to a new environment, could experience significant changes in a matter of generations. This raises the question, could we be witnessing a kind of quantum evolution in action? One phenomenon that supports this idea is genetic variation. Species that reproduce through methods that allow for greater variability in their DNA, such as unicellular organisms, may be more subject to these quantum mutations. This could explain why some species seem to adapt more quickly to changes in their environment, as seen in certain microorganisms that develop resistance to antibiotics in a surprisingly short time. And not only that, quantum mechanics could be behind the way species interact with each other. What if the chemical signals that organisms use to communicate were influenced by quantum phenomena? This could lead to new forms of cooperation or competition between species, altering the course of evolution in ways we do not yet fully understand. Some scientists are beginning to investigate how quantum mutations might be related to phenomena such as epigenetics. This field studies how environmental factors can affect gene expression without changing the DNA sequence. If quantum mutations play a role in this process, we could be facing a true paradigm shift in evolutionary biology. In the search for answers, more questions arise. How can we study these quantum mutations? Science is constantly advancing, and the intersection between biology and quantum mechanics is a fertile ground for research. The creation of models and simulations could help us unravel these enigmas. But we are still at the beginning of this journey. The possibility that quantum mutations influence evolution invites us to rethink our understanding of life itself. Instead of viewing evolution as a linear and rigid process, we might begin to conceive it as a much more dynamic phenomenon where quantum uncertainty plays an essential role. In conclusion, quantum mutations could be at the heart of how species evolve and adapt in a constantly changing world. This intertwining of quantum mechanics and biology opens new doors to our understanding of life and the universe. Science continues to explore these mysteries, and each discovery brings us one step closer to unveiling the complexity that lies behind the simplicity of existence. Evolution, like quantum mechanics, is a journey full of surprises, where each new finding can change our perception of what it means to be part of this vast universe. The quantum revolution is not just an abstract concept belonging to the world of physics, it is an open door to new ways of understanding life itself. What if I told you that the mysteries of quantum mechanics could be the key to unveiling the secrets of biology? From photosynthesis in plants to the way our own cells function, the influence of quantum mechanics is deeper than we could imagine. Let's think about photosynthesis. Plants, those green beings that adorn our gardens and parks, are true energy factories. But how do they manage to convert sunlight into food? The answer lies in quantum processes that allow them to capture solar energy incredibly efficiently. The molecules within the leaves, like little dancers on a stage, move and vibrate in such a way that they can harness every photon of light that reaches them. It's as if they have a superpower that enables them to perform magic with light. As scientists delve deeper into the mechanisms of photosynthesis, new questions arise. Could it be that the quantum properties of the molecules are what give them that advantage, instead of simply absorbing light? Could they be using quantum mechanics to jump between different energy levels more efficiently than classical physics could explain? Imagine a race where the runners not only run but can teleport along the track. That's how astonishing what quantum mechanics might be doing in the natural world. Quantum biology doesn't stop at photosynthesis. There is also evidence suggesting that quantum mechanics could play a role in how animal senses function. For example, some studies have shown that the sense of smell might be influenced by quantum phenomena. How is it possible that our brain can recognize thousands of different smells so quickly and accurately? The answer might lie in how odor molecules interact with our olfactory receptors at a quantum level. It's as if each aroma has its own melody, and our brain is an expert musician capable of distinguishing each note. The mysteries don't stop there. The migration of birds is another fascinating example. Have you ever seen a flock of birds flying in perfect formation, traveling thousands of kilometers with astonishing precision? Science has suggested that these birds might be using quantum entanglement to navigate. Imagine they have an invisible map inside them, one that allows them to know their exact position in the world, even at astronomical distances. That instant connection between particles is like a secret message that only they can read. The implications of quantum biology go beyond what we can observe at first glance. Evolution, that process that has shaped life on Earth, could also be influenced by quantum mechanics. Is it possible that mutations, those small changes that occur in our DNA, are determined by quantum phenomena? The idea that genetic variation could have a quantum component adds a layer of complexity to the already fascinating story of evolution. It's as if nature is playing hide and seek at a level we have yet to fully comprehend. The quantum revolution also invites us to rethink what we understand by life. If the laws of quantum mechanics can influence fundamental biological processes, what does this mean for our understanding of the universe? The divide between physics and biology becomes blurred, and we discover that all aspects of life are intertwined in ways we never dreamed. Life, in its essence, may be a quantum phenomenon in itself. Quantum biology not only opens new questions, but also offers the opportunity for innovations in fields such as medicine. Imagine treatments that use quantum principles to target diseases at their most fundamental level. The possibility that quantum mechanics could help us develop new medications is a horizon filled with hope. Science is advancing in this direction, and every day we discover more about how these principles can be applied to improve our health. However, it's not all smooth sailing. As we delve into the world of quantum biology, ethical and philosophical challenges arise. What does it mean to be human in a universe where the laws of quantum mechanics dictate our lives in such profound ways? The boundary between what we know and what we don't know becomes blurred, and we face questions about our own existence and the place we occupy in the universe. The quantum revolution is transforming our understanding of life, but it is also leading us into a new era of exploration and discovery. Each new finding is like a piece of a puzzle that brings us closer to understanding the mystery of existence. As we move forward, it is vital to keep an open mind and be willing to question our most fundamental assumptions. Discoveries in quantum biology not only fascinate us, they also remind us that science is a continuous journey of learning. It invites us to be curious, to ask questions, and not to be afraid to explore the unknown. Quantum mechanics is here to stay, and its role in the fabric of life is just the beginning of a story that is only starting to unfold. The quantum revolution is, ultimately, a reminder that the universe is an extraordinary place full of surprises. It shows us that as we delve into the mysteries of nature, each answer generates new questions. Life, in its complexity and beauty, is a testament to the wonder found at the heart of quantum mechanics. And so, the journey continues, taking us to corners of science that we have yet to explore. The universe, with its vast and mysterious complexities, resembles an immense puzzle that, despite its magnitude, can be understood through a series of small pieces. Each discovery in quantum mechanics has offered us a new fragment of that puzzle, revealing a reality that challenges our intuition and invites us to question what we thought we knew about life and the universe. What does all this really mean for us? How does it affect our perception of daily life and our place in the cosmos? Reflecting on quantum mechanics, one might wonder if we are alone in this vast universe, or if there is something more interconnected between us and the particles that surround us. The idea that small particles can be instantaneously entangled, regardless of distance, suggests that we are more connected to everything around us than we ever imagined. Could it be that our actions, thoughts, and emotions have an impact on this quantum network of interconnection? Amazement also extends to our understanding of life itself. Quantum biology raises the possibility that the fundamental processes that give life to humans and other organisms are guided by the same rules that govern the behavior of subatomic particles. Imagine for a moment that every breath we take, every thought we formulate could be tied to these invisible quantum principles. Isn't it fascinating to think that the essence of our existence could be intertwined with the laws of the universe? As we explore further, another question arises. Can quantum phenomena influence our evolution as a species? The answer could be more intriguing than we think. Mutations, which are the engine of evolution, may not simply be the result of environmental and random factors, but could also have a quantum component. Is it possible that nature uses quantum mechanics as a tool to innovate and adapt in ways we have yet to fully understand? The quantum revolution, then, is not just a series of scientific discoveries. It is a paradigm shift that is rewriting our understanding of life. Each new finding in this field not only reveals the complexity of matter, but also illuminates the simplicity of our connection to the universe. What if, instead of seeing ourselves as isolated beings in vast space, we began to recognize that we are part of a much larger cosmic network? This shift in perspective could open the door to new ways of understanding our relationships and our impact on the world. The implications of quantum mechanics go beyond science. They challenge us to reconsider our philosophy, our spirituality, and our relationship with nature. How does this affect us in our daily lives? Every choice we make could resonate in the fabric of the universe, and that idea can be both liberating and overwhelming. Are we ready to take responsibility for our connection with everything around us? In this search for meaning, we may also find comfort. Quantum mechanics teaches us that, although reality may be strange and incomprehensible, there is an underlying order that governs apparent chaos. This order is not always visible at first glance, but it is present in every corner of the universe. Isn't it reassuring to think that, despite the uncertainty of life, there is a logic that unites everything we know? And as we reflect on our existence, we can find inspiration in the beauty of this interconnection. The wonders of nature, from the migration of birds to photosynthesis in plants, testify to how quantum mechanics is intertwined with every aspect of life. Shouldn't we celebrate this connection and seek ways to live in harmony with the world around us? Quantum mechanics also invites us to be curious and to keep exploring. Each discovery in this field opens new doors and raises more questions. What mysteries still await us? Science is a continuous journey, and each step we take brings us closer to understanding our reality. So what does the future hold for us? The answer may lie in our own hands, in our willingness to question, explore, and learn. Ultimately, as we look to the future, quantum mechanics reminds us that we are part of something much larger. Each of us, with our experiences, thoughts, and emotions, plays a role in the grand theatre of the universe. What story will we leave on this cosmic stage? The choice is in our hands, and each day is a new opportunity to write another chapter in this incredible narrative. Let us reflect on our place in this vast universe. Quantum mechanics not only offers us answers, but also leads us to question our own assumptions and beliefs. What can we do to embrace this complexity while finding simplicity within it? The answer may be as simple as opening our minds and hearts to the infinite possibilities that surround us. So when you think about the universe and your place in it, remember that every small fragment, every particle is connected in ways we are just beginning to understand. Quantum mechanics is not just a field of study. It is an invitation to marvel at the complexity of life and to discover the beauty that lies in the unknown. And in that journey, perhaps we will find not only answers, but also a deeper sense of connection with everything around us.